Oh, good morning, good afternoon, everyone. Welcome to the AESQ Process Control Methods Subject Matter Interest Group Teams webinar entitled The Three C's of SPC, Control, Capability, and Centering, in that order. My name is Pete Teti. I am the PCM SMIG team leader, and I am accompanied by my cohort, Dr. Ricardo Banulis of Rolls-Royce. And Ricardo, if you'd like to introduce yourself, talk a little bit about yourself, and I'll do the same.
Yeah, sure. Thank you, Pete. Yeah, as Pete mentioned, my name is Ricardo Bañuelas. I have worked for Rolls-Royce for nearly 20 years now, half of the time in the UK, half of the time here in the US. I'm based in Indianapolis, and I'm the head of continuous improvement and quality for North America. So I say based in Indianapolis, I'm also a master black belt. I regularly do some lectures with Michigan State University. So actually going to be next week over there. So looking forward to that. And I'm also co-author of some of the reference manuals and a book called World Class Application of Six Sigma.
Thank you, Ricardo. And again, I'm Pete Teti from Pratt Whitney. I'm in my 40th year between Collins Aerospace and Pratt Whitney. I'm a fellow and senior fellow in quality engineering, and also ASQ certified quality engineer, auditor, and manager. I serve as an adjunct professor in my 25th year at Central Connecticut State University, teaching courses in Six Sigma, and have been heavily involved in the writing team for AESQ, along with reference manuals 13,006 and 13,000. Looking forward this morning to working with you. We have a jam-packed agenda, folks. A lot of good material here. So we're going to get right to it. I'll start off with a welcome and overview, and then we'll get into the first C, control. And then Ricardo is going to take us through the second and third C's, capability and centering. And then we'll do a Q&A. And we also have some interaction planned for you. So this webinar is being recorded by the AESQ. It will be posted along with this presentation on the AESQ website after today. I expect that within a week or so. And then you could use this material for your own internal training purposes. We'll take questions today during the webinar, but we're also going to do some polling. We're going to be utilizing the polling function in Teams today for our first time. So that should be a lot of fun. We were trying it out earlier and it works really well. So we'll ask you to please remain on mute during the presentation. Again, just to keep it, prevent any background noise. So we're going to start off right now with our first poll in your chat. Type one or two words that come to mind when you think of process control. What do you think of when you hear those two words, process control? You can utilize the chat poll function. What comes to mind when you think of process control? We keep hearing more and more about this today. It's the heart of Chapter B in AS 13,100. That's all about process control. Any results?
Yeah, Pete, it looks like the number one is variation, variation cause, process stability, process variation, SPC.
Mhm. All right, great. Wow, variation, that's a lot to what we'll be talking about. That's the inevitable difference among individual outputs of any process. And Deming, Dr. W. Edwards Deming, often stated, quality is largely the control and reduction of variation. So that's great. That's a great segue into our presentation this morning here. A little bit. I'm not going to spend a lot of time on the next few slides. They're kind of boilerplate, but they're important. The purpose of process control methods is to support the risk mitigation piece of PFMEA as we are, and design FMEA as well. When we're looking at identifying functional and process risks through the use of FMEA, we know that there are prevention and detection control columns in either of those two important tools, while process control methods per reference manual 13,006 supports that, along with properly written reaction plans. So check out reference manual 13,006. Also, later on, what we're going to want to know from you, what would you like to see added to that reference manual? We're always interested to know through our community of practice how we can improve the manual. It's your manual. It's not ours. Okay, we're here to serve you in trying to put this reference manual and make it value added for all of you in the process control community. And that's why we're here, Process Control SMIG group. We put on webinars. We are the managers, if you will, of that reference manual 13,006, trying to drive a culture of process control and, trying to do our part in that, in the implementation of Chapter B, AS 13100. And trying to provide tools that suppliers can use throughout our AESQ supply chain. These are the members of your SMIG team. And I'll tell you, this is a great team, very dedicated and very energetic. And we've got 7 webinars this year alone on tap. This is the first one. And you can see the different companies, a diverse set of companies that are represented on this team. And again, the control methods community of practice. I'm happy to say we've broke the 400 mark last week. We're at 409. We'd really like to get that up to 600 before the end of the year. If you're not a member of our community of practice, you've now been invited to become one. And we would love to have you, and we'd love to hear your questions and be part of our overall process control community of practice. This is the link up here. And again, we can put that in the chat. Another poll now, which of the 3 C's, control, capability, or centering, do you feel is the hardest to achieve? Which one do you feel, control, capability, or centering, is the hardest to achieve? Which is the hardest to achieve?
Right. We're getting some answers now.
Yeah.
So still some people are still responding. We have over 40 responses so far. It's interesting. 32% says control, 15% say capability. So it's more coming, more answer coming. Centering, CPK and PPK, 34%. All three equal 17%. So interesting. No one said no problem with all of the three. No one said that. So
what percent, Ricardo, was control?
33%.
33%.
So,
wow. Okay. Interesting results. Let's see where that takes us as we go through the presentation. This is a great segue again into what is we're trying to communicate with this webinar. So the 3 C's of SPC in a nutshell. Control measures the process behavior, its stability, and it simply asks the question, can we predict where the next measurement or the next part will be? You can see our little control chart up here, and it fluctuates the data within these control limits. That's the expected level of variation. And we're showing a nice predictable process here. Capability, which is measured by 2 different statistics. It's either Cp or P sub P, measures the precision, and the key parameters involve statistics computed the range or the standard deviation we call sigma. And it simply asks the question, do we have the potential to consistently meet the engineering tolerance? Can the car fit inside the garage? Finally, there's centering and 2 statistics that measure that, Cpk and PPK. And so we'll talk about the differences between those later. Ricardo's got a wonderful presentation on that. So that measures accuracy and precision, along with key parameters being the sample average and the range and the standard deviation. But the question that CPK or PPK will ask, are we targeted to the nominal dimension? So when I pull my car to the garage, maybe I'm not dead center, but I don't want to be so off center I'm going to hit a wall. And you can see the various types of potential outputs that we might see on a day-to-day basis. When do we say it's okay? And when do we say it's not so good? So the first C is control. And some of the key points that we want to bring out at this juncture is the importance of a process being under statistical control and how control charts per RM 13006 is a key control method that's used as a way to prevent causes of defects from happening. It's one of the control methods most popularly used to monitor a key characteristic. And operators need to be trained in the use of what's called the Western electric rules, the patterns that tell us whether or not we should ask a question and take action on a process. And we'll get into that later. So the overall purpose here of this webinar, many times we typically jump, when it comes into, when we have process control requirements for product features identified as a key characteristic, or it might be a key product characteristic, we tend to jump right to process capability and start calculating CP and CPK without any thought about what the control aspect of the data we use to calculate those statistics came from. So we need to first understand, before we jump to calculating process capability statistics, can we predict where the next part will be? Is the process behaving in a way we would expect it to? And not having contamination due to what Dr. Deming calls special causes of variation that we need to eliminate. Is the process stable? Is it in statistical control? So this is what we're going to be emphasizing in the first part of this webinar. And here is the good doctor, words from the good doctor. This is one of his more famous quotes. And he said that a state of statistical control is not natural in a manufacturing process. Processes like to go out of control. There's a lot of variables that need to be understood and have standard work behind their control. And it takes a lot of work to do that. And that's what Deming's trying to say here. So it's an achievement when we have a process in statistical control. And we do that by eliminating the special causes of variation. He had a very big impact, in the field, in the science of quality, as we know, W. Edwards Deming. So one of the tools that a gentleman that Dr. Deming worked for was Walter Shewhart in the 1920s. It was Walter Shewhart who invented the control chart way back 100 years ago now. And control charts are a graphical display. They show the behavior or the heart rate of the process when we plot points in time order. And the control charts, which have statistical control limits, provide the expected level of variation. It basically provides the voice of the process. And it can tell us through signals of unusual patterns whether or not an operator ought to make an adjustment or take action or get help regarding that process. So that's simply what it is. And it's a very effective control method if used in the right way. There are many types of control charts. We're not going to get into all the different types. That's not the purpose of this webinar. We will do that in additional webinars. We'll get into some specialty areas, group charts and, exponentially weighted moving average type charts. Those are things, multivariate analysis, that's common. But for today, we're talking about the very basics. We're showing an individual control chart up here. This is probably the one that's used most of the time based on the lot sizes we see. And the types of variation that can be detected within a control chart, if it's in control like this graphic shows on the upper right, then it's subjected only to common cause variation. That's what's expected to happen. That's natural. It's also out of the operator's control. It's produced by the system that the operator works in, with the work instructions, the tooling, the measurement equipment, the environmental factors that are given to the operator to work in. Deming says 85% of all variation comes from common causes that can only be reduced by management action, not by the operator. But the operator can influence special causes of variation. That's about 15% of the variation that occurs on a day-to-day basis from a process. And it happens for some attributable or identifiable reason. And that's where the operator needs to take action and not ignore when they see a signal like in the bottom right here. I'm pointing to this point that went out of control. That tells the operator, stop, take action, investigate, and make the right adjustment. So control versus capability. This really needs to be understood because these are mutually exclusive of one another. Control is all about stability and predictability. Okay, a process is said to be in statistical control when we iron out all the special causes of variation and it's only running subjected to common causes. Then these tools, these control methods called control charts, can help us determine whether we're operating to just common cause versus special cause variation. And that's good. That means we have a predictable, well-behaving process. Doesn't mean it's capable, though. So capability is the ability to make sure that every measurement falls within the engineering tolerance in a consistent way, and that, we're targeted to the nominal dimension. As we can see in this bell-shaped histogram, the first one here, looks like everything is centered and well within the lower and upper spec limit. That's a good thing. The second histogram shows we've got too much variation. We've got a big truck trying to fit inside a small garage, and guess what? It's not going to get in there. So you might as well make it a tool shed because that truck's not getting in there. And so I happen to have an old garage, and that would actually be the case for me. So my brother brought over an F-150, and that truck would not fit in my garage. It doesn't have the capability. And then look at the bottom bell on the bottom right. We've got a capable process, but it's not centered. The accuracy of that process isn't good. It's biased from the target, and that requires action. So capability and control are different, but they absolutely work together. But first, we have to have control. So, polling question, is statistical control important? Is it important based on what we just said? Is it important? Or can we just bypass it? We don't need to worry about the behavior of the process. It's a big deal. Let's just calculate the capability. Is that what we want? Or should we take statistical control into account?
Right, we have some results so far. Majority people say yes, but the people who answered the poll are saying it's almost half and half. So one half say for consistency of results over time is 42%, and the other half says to allow accurate predictions of future capability. So
beautiful, 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 Ricardo. So, and again, that's where we're leading into why control and what its impact is on capability. So the impact of an out of control process has on capability. A lot of words here, but they're all important. Capability statistics, as we talked about just briefly, they can drastically be impacted by whether or not the process is in control or not. And so if the process is originally out of control when the capability is assessed, then that's going to have a negative impact on that capability calculation. It may have a wide level of variation that really isn't representative of the process. There might have been some assignable cause that needed to be worked out and excluded from the capability calculation once we understand what it is. So only capability statistics, they're only reliable when they come from an in-control process, okay? Again, out of control, could be driven when we don't have good controls on the nuisance sources of variation, like raw materials, setup to setup, batch to batch, machine to machine, temperature to temperature. These are all types of variables that have to be controlled, and they get controlled through standard work. Then on top of that, you have the measurement systems that we use and the equipment that we're using. So Some of these variables affect the long-term variation over time, and others affect the short-term variation in a small period of time. And it's important that we understand the difference. Out of control variability can be driven, again, if I'm not controlling my equipment, if I have poor measurement system capability. That's an interaction point, by the way, to RM 13003, our MSA manual. That's our MSA reference manual, measurement systems analysis. If our operator onboarding or inspector onboarding is not good, if we don't have good training on how we bring on new people, and we do that every day. So that's important because that sets the stage of how they'll operate. And again, calculating these statistics is not hard. It's a piece of cake to calculate, but what's the data like that we calculate them from? We don't want the data to be contaminated. And so again, our emphasis here is to ensure that we have good data used to calculate process capability indices with. And that means that that data comes from a controlled process. Impact of an out of control process, again, on capability. Sometimes, like we'll see, when we're using the most popular types of control charts, individual and moving range. If you take any of these control charts that are really the most common, IXMR, X bar and R, which is the X bar in range, X bar in sigma, these are control charts that have the assumption of normality. They assume we're dealing with a normal distribution, especially the individuals chart. And when you're dealing with averages, that assumption of normality is not such a big deal because averages tend to be normally distributed. Despite the distribution that they come from, averages are going to be normal. That's the central limit theorem at work. But individuals values, when we have small lots, we're using individual data. A lot of times we may find that they're non-normal. Well, what can cause non-normal? If we calculate process capability indices from non-normal data, those capability statistics assume a normal distribution. We're going to be in trouble. We're going to get capability indices that aren't reliable. Now we got to ask, well, why is the data non-normal? Is it non-normal because it's supposed to be non-normal? Is it supposed to be another distribution, exponential, geometric? Or is it non-normal because of assignable causes being present? So we need to first understand that, and that's why it's important to make sure the data is clean. And that's really what this slide is trying to say. In the yellow print, it gets right to it. Out of control data can result in control limits that do not represent the true process behavior, expectation of variation, investigating if the data is non-normal when it isn't. Okay, we may think it's non-normal and we're going to try to come up with another possible distribution fit, but we shouldn't even be doing that because of the assignable causes that cause the non-normality to begin with. So we might be reporting higher capability or lower capability than is truly representative of that process. Those are the things that can happen. And so one of the key prerequisites to process capability is that our process is in a state of control. And the only way to evaluate that is the use of a control chart. That's what it does. It helps us to know whether or not the process is behaving in a stable way. So you'll know that the factors driving the response, the key characteristic in this case, are in control, by looking at the chart. and the use of the Western Electric rules, which we will see coming up. What are those patterns we should be looking for? So we've got some examples here showing a nice, steady state of control in the depiction on the left. In the middle, we have a process that looks like it's getting a little bit wide in its variation and may even have a trend starting off, in the beginning run of that data. And that might be something we should look at and understand. At the very bottom, we can see averages that are high, and then they get into the targeted area. We need to understand why we had a bias in the beginning. What drove that shift? What factor or factors were behind that? And so, again, this type of data that has these trends or these shifts in it are going to negatively impact the process capability statistics. So what do we do? What do, I should say, the control charts evaluate? What do they evaluate? Averages, if we're plotting averages, subgroup averages, maybe we're going down, we have a high volume operation and we're pulling 4 parts every hour, calculating the average and the range and plotting those statistics on a control chart. Averages variation is typically due to long-term between subgroup sources. That includes temperature, raw material, people differences, setup to setup, operator to operator, shift to shift, measurement system and tooling. Short-term variation, which comes from the range, from a set of 4 measurements made in a much tighter time period. It might be a few minutes. It might be, 10 minutes to get 4 pieces. Well, not a whole lot's going to change in that short period of time. So what's going to drive that will be measurement system variation, axis, lead screw wear on a piece of equipment. Those are short-term within subgroup sources. So here we're just trying to define the difference between and within, short-term and long-term. Long-term is typically illustrated by the averages and short-term by the ranges. And here's our Western Electric test for control. These patterns are unusual if data is supposed to come out of a normal distribution. And so the very first test shows a point outside the 3 sigma limit. And then you can see like test number 5, where we've got a trend. That could be a trend upward or downward, a sawtooth pattern, a run, test 4, a run of data. Why are we biased from the average point? And again, I won't go through every one of these, but these are the patterns that an operator ought to be trained in to look for. Now, if one's using real-time SPC software, that's usually built right into the software. The operator doesn't have to worry about it. They'll get a signal right from the software. If you're not using automated real-time software, then a laminated copy of this slide would be a good idea if we're using manual control charting. And there's nothing wrong with that. But let's make sure that we know how to react to these types of patterns. So with that said, I am now going to turn it over to my teammate, Ricardo, and he's going to take us through the second and third C, capability and centering. All yours, Ricardo.
Thank you, Pete. So yes, I'm going to take you to the second and third C's of SPC. So the second is capability and the third is centering. So I have a few slides for both of them, right? We're also going to cover a little bit about the short-term variation and the long-term variation that Pete touched a little bit on that. And I'm going to conclude by going to some of the key ways to improve control capability and centering as well. Go to the next slide, please. So the second C of SPC is capability, right? I've here a bit of definition for you. So capability is the ability of the process to produce output that consistently meets specifications, right? So the first C that Pete was talking about, it doesn't necessarily take in consideration customer specifications, right? Everything's about control limits from the process. On the second C, we introduce the voice of the customer through the specification limits, right? So we can have a process that is well in control, but we fail to meet specification requirements, right? So we might need to take some steps to improve or redesign the process. And that's where these problems where we call it the voice of the process exceeds the voice of the customer. So you look here at the graphic here, you see two histograms. So the first one, most of the population fall within the specification limits. So you almost predict here that 100% of the population will be within the specification limit. So you have a capable process. In other words, the car fits into the garage, right? The second example, you see some of the population going outside the control limits, right? So the car will not fit into the garage. So you need to reduce that variation in order to meet the customer specification. So capability is about making sure that your process fit into the garage, if you like, right? So let's talk a little bit about the indexes that we use for process capability. The next slide, please, Pete. So we have two types of indexes that we use, or statistics that we use for measuring process capability. So many of you are familiar with CPs and CPKs and PPs and PPKs. They use very similar calculation, but it's a key difference here between the two of them. So the CP and CPKs is about the potential capability. It's a key word here, is the potential capability. Whereas PP and PPKs is the process performance capability, is what you actually see. Both are computed very similar, they use sigma, but the key difference here is how the sigma is calculated, right? For CP and CPK, you use the sigma short term or the sigma hat, something referring like that. And for PP and PPK, you use the sigma long term. You can see the equation here, right? So this one, it looks at the short term, the CP and PP look at the short term, and the PP and PPK look at the long term, right? So both calculations are similar, and it could come very, very close to each other, right? If the process is relatively free of any additional long-term variation, right? If you have long-term variation, the process most likely to be out of control. So this is why they are different, right? If we go to the next slide, I can elaborate on this a little bit more, right? So let's see an example here between the short and the long term. So we talk about the different ways to calculation, but because the short-term sigma, most likely the variation will come from the machine and the measurement only. So you are looking at a specific point of time where you probably don't introduce other variations in the long terms, such as raw material or time or different operators or different adjustments or different setup. You look at on the short term, what you will see in the variation is usually machine and measurements, right? And so that's the difference between the two. Which one is better, which one is worse? I think it's probably not the right question on that. It's more about what everything measures, right? I say, if you want to demonstrate the capability of the process, the potential capability, you go into the short term. If you want to look at the performance, you look at the long term. So Minitab always calculates that for you, and you can see an output here. So the top chart, if you look here at the standard deviations, they are very similar, short term and long term, they are very similar. And therefore, the CP and PPKs are very similar to the PP and PPK. Also, the curves here, the red and the and the black curves are very similar. So that tells us that the process is likely to be in control. The short and long-term variability are very similar, so you can predict capability based on these conditions. In the bottom chart, you see that the standard deviations are different, right? You see that the CP and PP are different. So if you claim capability based on the CP on those difference, it's probably not a true reflection of what the customer will perceive. So you need to be very careful when you see that, because most likely there is other source of variation that is driving that. So in the short term, you can be very good, but long term, you are not good. That's what the customer says. So you need to investigate what is happening here. And we're going to see some examples how to do that. Look at the curve. The curve's red curve is nice and centered. We know a lot of variation, but the long term is flatter, and you will see more potentially poorer capability on that on your PP and PPKs. Okay, next slide, Pete, please. So let's talk about the third C, which is centering, right? So we talk about control, we talk about capability. So the third C is going to be centering. So as we discussed before, we can have a process that is in control, but still not meet the specification requirements, right? It can be they have too much variation, as we saw in capability a moment ago, or it can be because the distribution of our process is bias or shift. So you look here at the histograms here. We talk about the first process, which is nice center, low variation, maybe only, potentially 100% of the population fall into the specification limits. You have most likely a very high CP and Cpk. But the next one, on the third example here, you are shifted to the right, right? So you have the potential of being capable, and that will be showing your CPs and PPs, but you will have a lower Cpk. So what you need to do here is try to center the process in this case, right? Mm-hmm. So in the garage example, you might be hitting one of the walls, so you need to adjust the way that you get into the garage so it goes nice and centered, so you don't have any issues, right? And you don't hit the wall. So that's the third C. It's about centering your process. You're already in control. You know that you have low variation through capability. So now you need to make sure that you hit the center of the specification, right? Go to the next slide, Pete. So let's look here examples here in Minitab, right? So trying to sum up that we discussed, right? So we have two cases here. Many of you use Minitab, and this is the 6-pack that you do when you collect data in Minitab. So the left-hand side, the process is in statistical control, so we can use capability and analysis. The right-hand side is not in control, so using capability analysis will be totally useless, right? So look here on the X bar and R chart, everything is in control, right? You look at the variation as well on the subgroups. It seems like a randomly distributed between subgroups. You compare that one to the right-hand side, like you have low variation in your subgroups, but overall high variation, right? So that indicates that the short-term variation and the long-term variation are different. So you really need to investigate what is driving that short-term variation versus the long-term variation. In this case, just by looking at the charts, you notice here there are some points that are outside the control limits. So that points you to, hey, let's investigate this out-of-control process, out-of-control points, to see what is happening to the process, right? Because you have this out-of-control, it will drive probably a distribution that doesn't gonna look normal, and a CPK and PPK that are different from the PP and PPK, right? So it's why it's so important to look first at the process control, identify those variations outside the control limits, right? The first thing that you do, one that you have the control, you start looking at the CPs and PPKs. So, but that's how everything ties up together, right? Our control leads into non-normality, it leads into variation in your sigmas in the short and long term, and variation in your CPs and PPs and CP CPKs and PPKs. So all of them tied together, right? Okay, next slide, please, Pete. So this is a journey to improve, right? So when Pete was talking about the 3 Cs, we saw control, capability, and centering, and even the title say in that order, is for this reason, right? So here we have a hypothetical example where you have a process that is not in control. So you see from the chart, the control chart, that you have some points outside the control chart or the limits of the control chart. So you need to address that first. In this hypothetical example, they got a new tool. After getting the new tool, you see that they reduce the variation. So now you are in control, more predictable what is going to happen to the process. You have process control. Now you see that you have process control, but you need to work in centering the process, right? So they develop a new type of locating system, and then they move the mean to the target, and it's all linking nicely together. So you have process control. Now you have capability. Now you have centering the process. So that's the journey that we normally take in that order. Is the way that we recommend it to use. So if you go to the next slide, I'm going to show you some examples of how to do that, right? As I mentioned, have the control, the centering, the capability on the left-hand side. But let's look at the ways to improve here. And it's more real case application of the product that we produce in aerospace, right? So first thing that we recommend to do is the measurement system, right? You need to look at your measurement system. You have a measurement system that is capable, you can start using your process control chart. If it's not capable, you add in variation where it's not needed, right? The product might be good, but your measurement system is not, it's not great. The other thing that we normally do, and we do here in the plants that we have in Rolls-Royce and other parts of the world, we look at the machine capability. We look at the what we call asset care or total preventive maintenance. Looking at all of this first, right? Is the machine in a good condition or not? Is the tool in a good condition or not, right? One that you know, hey, I have my good measurement system analysis, my machines are repeatable, they are in good asset care, it's been taken care of. You start looking more at other aspects, such as standard work, where the variation is coming from the operator to operator, is coming from different ways of the operator doing the operation. Do we have standard operation procedures to do that? That's what we started looking at. And then towards the end of this journey, you start using root cause corrective action, looking at your ADs, right? And do a root cause analysis. What is that driving? Having this data, it really drives improvement. It really drives root cause analysis. One thing that we really keen on is to make sure that this data is real-time data, because trying to find something that happened 30 days ago is really hard. But if you are monitoring this every day, every shift, it's more likely that you identify what the root cause of a special cause is, right? So it's very, very important that it's a live document. It's not something that is analyzed a month after it's been collecting the information, right? Okay, we can go to the next slide just to bring everything together, right? So let's talk here about the relationship between the control charts and the process capability, right? So how we discussed previously, in the present state of control without a special cause of variation, they have these characteristics. We talk about Cp and PPKs, Cp and Cpks closer to PP and PPKs. That's because the short-term variation, the short-term sigma, is equal to the long-term sigma. So it's no special causes there, right? You will see that the process will exhibit very few to no outliers, right? It's gonna be normal when expected to be normal, right? Some cases it's not normal because the nature of the process is not normal. So long-term variation is equal to the short-term, and the measurement system is capable, right? If your measurement system is not capable, you will see probably more variation than you will expect, right? So You see here the difference. Those are the key points that you to look at when you use user analysis. Every time that you use your Minitab 6-packs, look at all these points, and they will tell you where to focus, basically, right? And I believe that's all of these slides for me, Pete. I think you go to the next slide. I think that's for you. Yeah.
Excellent, Ricardo. Thank you so much. That was wonderful. Now we're going to drive toward a conclusion. So some key points here will be the bottom line of today's webinar. And of course, we want to thank you for your attendance and talk about some next webinars that are coming up. So again, just kind of reiterating a little bit of what Ricardo just said on the bottom line of the 3 C's. Let's have the process in control. Let's make sure it's in control first and foremost. Control is the first and foremost of the 3 C's. Then we can talk about process capability. Emphasize the use of SPC control charts. And Ricardo mentioned at the workstation, not 3 operations later, or 2 days later. Filling out the control chart then is just like reporting the news. Could tell you what happened, but it's not a control method at that point. It can't be useful for taking action as the process is running in real time. Make sure operators do understand the use of the Western Electric rules. Those were contrived by Dr. Deming and Dr. Schuhart way back in the 20s as a means of knowing when to take action and, equally important, when to leave the process alone. It doesn't make a difference really which capability index you use if the process is in statistical control. If the long-term and short-term variation equal each other through the rigorous use of standard work, control of equipment, asset care, control of raw materials, temperature, those nuisance variables, it really doesn't matter whether you're using Cp and Cpk or Pp and Ppk. As Ricardo showed, the standard deviations that govern each of those tend to come together. And finally, statistical control drives normality in the data for most situations. And why? Because control charts are based, the most common ones, on the normal distribution. So it stands to reason when they're in control, they're illustrating a normal distribution. You don't have to worry about that. So again, unless the requirement, though, like a geometric tolerance, like run out or true position or flatness, those will have boundaries. And yes, those will be treated a little bit differently. So coming up on our schedule, and this is all posted in the AESQ website under activities and upcoming events. So upcoming events, and that's under activities. We have a series of webinars. The next one will be on implementing individual and moving range and target to nominal charts. So we're starting to get a little more laser focus on some of the specific tools. And then how to choose which control method you need. Useful but less known control chart methods. That should be a really, really awesome one there that gets into multivariate type charts. The use of 3D charts when we're taking multiple measurements within a chart and we're looking at uniformity within a part. That will be very, very useful topic. Dealing with non-normal data, process control for manual data collection, and finally, how to assure successful SPC implementation. That's what's on the docket. But we do want to hear from you about what webinars you may want to see. Maybe we didn't, come up with all the right topics, and we want to hear from you. And that's where you can let us know on our community of practice, become a member of that, and let us know what you're looking for. So now we're going to do a Q&A session using the chat function to ask a question. But I think before we do that, we're going to do a group interactive quiz. Yes, we want to do this first. So let's do that, and then we'll go back to the Q&A. So the first question that we have for you, what's the difference between CPK and PPK? Pick the best answer. So you can have a series of answers. You tell us which one is the best. Give you a minute for that.
Have some answers coming in.
What is the difference? CPK and PPK.
The quiz is still live, so I cannot see the results yet. So.
Yep. Yeah, this one will take a little more time for sure.
Right, I cannot see the results for some reason. I was seeing them before, but just look here at the answers. Most of the people went with the short-term versus long-term, so PP and PPK, right?
Right.
Or say, yeah, some people say, hey, CPK equals short-term, PPK long-term. So at some point when I was looking at I don't know, you can see the results, Amanda. I don't know, you can show it quickly.
Sorry about that. It's probably because it's a quiz. So the correct answer was CP represents the process potential or short-term capability, while PP represents the process performance. And we had 83% answer correct.
Excellent.
That's great.
And if any of you ever take the certified quality engineering exam and you really don't know the answer, pick the longest answer.
Yeah,
but you got it.
Yeah, no, thank you. No, the key, how we explain, the key is the way that it's calculated. The formula is very similar.
Yeah.
What is different is the sigma, right? So the sigma that we calculated on CPK, the short term, right? The within the subgroup, and the PPK is the long term sigma. So that's the difference, right? When we do the analysis, we want to see these two very close to each other, right? That will tell us that we are in control, right? If you see results that are very, very different, we might need to investigate what is driving that, right?
Yeah, great job. And as mentioned, CP and CPK process potential and PPPK process performance. That comes out of the Automotive Industry Action Group, SPC reference manual. They define those terms. We use the same. Okay, let's see here. Oops. That's the same question. Not sure why I'm getting the same. Here we go. How would you know if a process is in control? How would you know if a process is in control?
Yeah. You're gonna remind me because I was feeling it's gonna disappear. I put it in a safe spot, but.
Right. I think the majority of people answer. Amanda, I don't know, you want to tell us the results?
So it looks like we had 46% say the capability index, CPK or PPK, is greater than 1.33, and also 46% say the Western Electric rules or a subset are not violated. And that was the correct answer, the second one.
Yeah, thank you, Amanda. So yeah, I think is what we're looking here for is in the correct answer. We're talking about here process control. So the Western Electric rules evaluate how well the process is under statistical control. So that's the correct answer. CPKs, CPs, PPKs, all those indices is for process capability. That's how we're gonna know if the process is capable. But if the process is in control, is against the Western Electric rules. I know you want to add anything, Pete. Then we need to unmute Pete.
Yeah, Pete, you're on mute.
I'm sorry about that. Let me reshare. Oh, I'm still sharing. Okay. So all I would say is that when CP and P sub P, CPK and PPK are getting close to being together, the same value, when that sigma short term and sigma long term are getting close to each other, that's also an indicator the process is in control. But you'll see that through the control chart. All that has to tie off together. Excellent. Let's see, next question. Which one of these is a Western Electric test for statistical control? Which one of these that are listed is a Western Electric test for statistical control? We showed a bunch of them. I think there were 8 altogether.
So I think some people are not seeing the choices. That's what are probably typing them instead. Well, I can show the choices very quickly. That helps. Can you see the choices, Pete?
No, I can't. Let me.
I'm seeing them here. It looks like we have 22 responses so far.
Okay.
So the choices are a single result beyond a 3 sigma control limit, 15 points in a row hugging the center line, 6 points in a row trending up or down, 14 points in a row alternating up and down, or all of the above.
What are folks saying?
You got the results, Amanda?
I do. So we have 8% saying a single result beyond a 3 sigma control limit and 6 points in a row trending up or down. 69% said all of the above, which is the correct answer.
Excellent. Excellent. Yeah, those are all part of the Western Electric rule tests. And again, we want to make sure, those using control charts are trained in trained in those and be able to understand they need to use those signals to manage the process and when to take action and when not to. Hey, so let's see. And here we go. Which one? Oh, I'm sorry, that's the wrong one. When should you quote capability indices or calculate them? When should you quote capability indices?
And the choices are, so people might not be able to see this. So the choices are after determining the measurement system is good. That's A. B, after collecting at least 25 data samples. That's B. C, after validating the process is running under statistical control. Or D, all of the above.
And what are we saying?
It looks like 82% have answered correct, which is all of the above.
Wonderful. Great. Good job, everyone. All right. Yeah. And again, this has been part of the theme of this webinar. You know, we don't just go right into calculating process capability. We need to understand if the data is good data, and good data means the absence of special causes. And that's, will give us reliable capability results. And I think, let's see. Okay. What would you like to see in a future process control methods webinar? This is more of a chat. I think they can just chat this in. What would you like to see in a future process control methods webinar? We have 6 more scheduled, but again, if something comes up that we might maybe we didn't think about, we can switch gears. If there's something out there you really need to see, want to see, and if we can help you do that, we will.
Do you know if, I don't know if you can see the answers, Pete.
No.
But people are saying more info on non-normal distributions.
Okay,
So,
great.
And it's good news because we have planned a webinar on non-normal distributions. So that's
Yeah.
coming.
Yep.
Similarly, transformation of non-normal data for features within physical boundaries. So that will be covered there too.
Yep. Yep.
More examples of common causes. MSA, FMEA. Let me see what else. Calibration and strategies how to get process under process control.
Excellent. Excellent. And just to reiterate, you can always submit us recommendations or ask questions anytime on the Community of Practice LinkedIn site that we have. So that's always available to you. Let's see. And lastly, and we'll go back to questions, how could future webinars be improved? You just took this one, and some of you may have been on some of our other webinars. Is there anything we can do that could improve whether it's the presentation, how it's delivered? We're more than willing to hear your suggestions.
One question,
Yep.
Pete, that drew my attention here. Someone is asking if we can share the material with suppliers and invite them to your group.
Mm-hmm. Yep. Yeah, we most certainly, we share this material, and just to let folks know, if we go on the AESQ website, which you can see on my screen, and if you go to events and go down to past events, you'll see all the various webinars that were provided in the past, and the presentation material and the video, because these are recorded. You can get access to that, and you can download the material for free and utilize that material in your own training. As you can see, we put a lot into these slides so that they can be used. We want you to use the material. And so there's a lot of great topics that were already covered. Human factors in FMEA, 1 hour process control assessment, the power of pre-control, past supplier forums and the materials from those forums. All of that's available to you. If you go up to the events and go to upcoming events, this tells you what webinars and forums are upcoming, and you can click and register for any of these. Okay. And so again, this is where you can get access to registering for the webinars that we just mentioned, and all the other SMIG team webinars. There's many more on their way, by the way. This is a short list. It's going to grow in a couple of weeks. Again, just wanted to share that with you. Also, if you go to documents and supplemental material, you can get access to all the gold books. Here's the reference manual 13,006, and tools and helpful checklists are also available here. This is all free material. So we're planning to beef this up with some new handy templates for process control purposes. That's coming. That's on its way. So we'll be sending out a notice through the community of practice when that happens. So again, that's a little bit on the website. And then let's go back. If there's any questions at this point for this, we have several SMIG team members on. If there's any questions about this webinar that you would wish to ask, feel free and go right ahead and ask. And we'll be happy to try to answer your question the best we can.
There were some questions about non-normal data, and would you recommend doing transformation of the data or identification of the data? I think some people respond to the to this curious already in the
Mhm.
in the chat. So it's really nice to see when someone asks a question, other members of the group answering straight away between them. So that's great. So we can encourage this as a community, right? So that's great that we're answering these questions. But I don't know, you want to add, Pete, anything about transformation of the data or not?
The one thing I'll say, first and foremost, make sure the data is clean and it's not contaminated with assignable causes. There's no need to do a transformation. Taking out the assignable causes might make the data possibly normal. But if it's truly proven that it's not normal and it's not due to special causes, I know in a seminar I went to at the Quality Congress for ASQ a few years back, it was in Charlotte, and I have a PDF that came out of a presentation from Minitab, and I highly recommend not to jump to a transformation, but first seek out a legitimate statistical distribution first. And, you know, when you have tools, such as, you know, Minitab or Jump or any of those statistical packages, they can help you do a fit of the data to determine the best fit distribution. If that fails, Minitab would say, then go to a transformation. That would be the process that they recommend. First, look for a true statistical distribution, then go to a transformation. So again, that's what I would also recommend as well. But first, look to see if there's assignable causes.
Right. No, thank you, Pete. And also, I would refer people to the reference manual. In the reference manual from page 40, pretty much section 7.
There you go.
Try to address all of this, and you have an excellent material, examples. So it goes from page 42 to page 55 or something like that. All explain about normal, what to do, what not to do. So it's a lot of information there. Also, there were some questions about the use of software such as Minitab. And it's great that people just chatting between them, say what Minitab can do, cannot do. But one of the things that we are aware that Minitab can do now is they can install on the shop floor and use real-time data in Minitab as well. There's other software that can do that. So that's really good. So you can use the data, analyze the data in real time as well.
Yeah, Ricardo, thank you for bringing up the reference manual. And there is an excellent guide in there in chapter 7, as Ricardo mentioned. So please feel free to go and use that. That basically explains the process for going around or going about handling non-normal data. Yeah, good job. Any other questions? Let's see here. Okay. Put this back up here. If there aren't any other questions, we geared this for an hour and a half, and we're 9 minutes short of that. We can certainly give that time back to all of you. We'd like to thank you for your participation and look forward to seeing you at our next webinar. Also take advantage of webinars from the other SMIG teams. I know the RM 13,000 team for 8D is working on one right now, the interaction of PFMEA and 8D. That should be really good. And and there's, I think, one coming out from the PFMEA team or the RM 13004 team, or that might already have happened. I forget. But go on that website and look up the upcoming events, and you'll get all the different free webinars coming up. So again, our invitation is always open to you to join the community of practice, and we thank you all for your participation and interaction this morning or afternoon, depending on where you're coming in from. Thank you all very, very much. On behalf of the Process Control Methods Subject Matter Interest Group team, we wish you a great rest of the day, everyone. Take care.
Thank you, everyone.